Welcome to Chemistry Wide. Today we will see basic organic chemistry. Let's see first inductive effect. What is the inductive effect? The electron shift towards move electronegative atom. It operates on sigma bond of an element to permanent effect. This is called permanent effect. For example, carbon atom. Carbon, we know that carbon atom, it is a tetravalent, it means 4 bonds. If carbon is single bond, it is going to sp3 hybridization. If carbon is double bond, it is going to sp2 hybridization. If carbon is triple bond, it is going to sp hybridization. This is the most fundamental basic. Next, we can see 3 topics. First one here, electromeric effect. Second one, mesomeric effect. Third one, resonance. Next, before we can see what is the reaction intermediate. See the memory this reaction intermediate, it may be carbon ion, carbocation, free radical, carbene or nitride. Next, nucleophile and electrophile attacking species. Next, types of reactive. See below, we can see at periodic table, fluorine atom is more electronegative element, but sodium atom is more electropositive element. So both are attractive each other. The electronegative elements gains the electron, the electropositive elements lost the electron. For example, if we take carbon chlorine bond, it is the sp3 hybridization. sp3 hybridization is always single bond. See below, this is the carbon, this is the chlorine. The chlorine is more electronegative element than carbon. See here, chlorine pull the electron from carbon and the chlorine forming electron cloud, because chlorine atom is more electronegative than carbon. See, if we take chlorine bond, chlorine molecule, it is same electronegativity, so electron exists at center, there is no movement. See below, in the between the chlorine atom, both chlorine has same equal electrostatic force, but in carbon chlorine bond, electron more towards the chlorine, so we can represent below like this. So chlorine is pull the electron from carbon, so it is attained partially negative charge. At the same time, carbon is attained partially positive charge. This symbol is dove. Here carbon attained partially positive charge and chlorine attained partially negative charge. Now like this. This chlorine is attract the electron because the chlorine valence electron is 7. See, we want 8 electron because it is going to change the octet rule. So the chlorine atom is pull the electron from carbon, so this is going through the bigger size. This side is small size. This side is called electron cloud because there is more electronegativity. Suppose if come more carbon atoms, it is going to see carbon, 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 chlorine. This chlorine is pull the one electron from this carbon, so this carbon attained partially positive charge. Again this carbon pull the electron from this carbon, so this carbon attained double partially positive charge. Again this carbon pull the one electron from this carbon, so this electron gets triple partially positive charge. This is called a triple state. This is called double state. See below. This is the partially negative charge. Sorry, I written mistakenly. Sorry. This is the partially positive charge. This is the partially, sorry, again this is attain the partially positive charge. This is going to partially negative charge. See below. Mostly all alkyl group is plus I effect. Mostly all halogen group minus I effect. I means inductive effect. Inductive effect means pull the electron. This alkyl group, see the periodic table as to at first row: lithium, sodium, potassium, rubidium, cesium, like this. These all are alkali metals. Alkali metals has positive I effect, and the halogen group is as minus I effect. For example, see below. This is the chlorine. Here this is the one methyl group, there is one methyl group, there is one methyl group. This chlorine atoms pulling the one electron from this carbon, this carbon pulling the electron, this carbon pulling the one electron from this carbon. See the arrow marks like this. Next, types of inductive effect. Plus I effect, another one minus I effect. Electron donating groups are called plus I inductive effect. For example, methyl radical and ethyl radical. This is the methyl, this is the ethyl. Minus I effect, electron withdrawing group. Electron withdrawing means electron is the pulling. For example, NO2, Cn, halogen, COR, or COCl, or COCH3, COCl, or NOO, or Cn. For example, this is the mostly common electron withdrawing group. Please remember this. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the mostly we can use. For example, CH3COOH, this is the acetic acid. It going to dissociate CH3COO minus plus H plus. This is going to dissociate below. We know that carbon always bonding to oxygen atom, it is double bond, because see the oxygen family. So another name is chalcogen family. Chalcogen family all are, it make double bond. Here CH3 C double bond O minus. Here this H plus going to attack the the H plus ion going to attack this O minus ion. This alkyl group electron releasing in nature, so plus I group. Here more electron density and is taking H plus ion again. Take H plus ion because this is a more electronegativity group or electron withdrawing group. H plus ion again, this is going to reverse or unionized form. See below. CH3C double bond O minus H plus, again going to revert. This is going to again revert. Again revert means this is going to again acetic acid. Here H plus ion's concentration is decreasing, so it is become weak acid. This is the main causes. For example, fluoroacetic acid is a stronger acid than acetic acid. Why? Because see, this is the fluoroacetic acid. This is going to dissociate this chlorine, pulling the electron from this carbon. So this carbon attain one electron. This is going to form double bond. Here O is going to one bond plus H plus. See, the K is concentration, A is acid. Ka equal to 1.4 into 10 power minus 3. But here see the acetic acid, this is here like this, C double bond O plus H plus. This concentration 1.73 into 10 power minus 5. This is the more acidic than acetic acid. This both values experimental data. Here K is the equilibrium constant. We can write below like this: Ka equal to equilibrium constant, the product concentration divided by reactant concentration. We can see below Ka equal to CH3COO minus plus H plus divided by CH3COH. Thanking you all. Please subscribe the video. More videos on the way. Very nice day.